Cool. So, oh yeah, that would be busy on Mother's Day. Ah, I love Olive Garden breadsticks. It's a great guilty pleasure. Alrighty, so let's see. So we're at week 6 right now, which is hard to believe, but here we are. Um, all right, so logistics first. I have canceled all my classes for Wednesday. So no office hours, and no class either section. I posted an announcement. I think. Um, and yeah, Tuesday I'm doing my second COVID shot, so that's Tuesday morning. So hopefully I'll be fine, by 10 o'clock, for this class. But if anything weird happens, I'll post a notice. But I'm planning on having class tomorrow as usual. But I'm planning on not having class Wednesday, so Thursday will probably be a regular lecture. Um, I'll decide tomorrow, but it'll probably be a regular lecture instead of a lab section because we got another week after that till PA4 is due. I've graded PA3, and I just posted the grades and comments for that this morning. Um, Again, really good work on the programming assignments. So a lot of games absolutely perfect. Um, Everybody's doing a really good job with commenting and formatting their code and styling it and that kind of stuff. So that's all fantastic. Um, if if you're not sure what went wrong with PA3, if you were having some issues or if you couldn't get it to a point where it would play or something, definitely come and let's talk through it. Right? Let's figure out what was going on. The big thing about PA3 was it had a number of different parts, but there were some fairly high level concepts there that had to make sense before you could write the code. I think if you got square on what was going to go where and exactly what each piece of your system was going to do, the coding may not have been that challenging, the compared to the organization and the planning up front, which is different from PA4. So PA4 is a lot of coding, and it's the implementation is a lot of the effort. But you also need to spend, the time like you did with PA3, sort of figuring out how things are going to be structured, what's going to go where, and so on, and then putting it all together is doable, but takes a lot of work. Lots of people getting second shots. That's fantastic. Um, cool. Yeah, hopefully these programming assignments are good learning experiences. In addition to maybe being a little more fun than what we did in 222, where it's like here's a tree, here's another tree, here's a list, which is fine, but hopefully these are working out. And yes, we do have our midterm on Friday, so we'll probably talk about that some Thursday. But I haven't written it yet. But kinds of things you've been doing in programming assignments, that's probably your best practice for getting ready for the midterm, because it's really just going to be some coding, some work with objects, defining classes, things like that, and Java, obviously. Cool. Good feedback on PA3. Thanks. Second shot right after this. Cool. All right. Any was there anything a lot of the class missed? So probably the most common issue people ran into, which is not surprising at all, was with updating the tree. And I had told you that's probably a good thing to leave for last, right? Get the gameplay working, get the ingest working. Most people that was working fine. The update is the trickiest part of the assignment. Um, and some people, made a good effort at that, and then weren't able to get it working correctly, and so in some cases just commented out that section of the code, so I could see it in there, and I could see how far they had gotten and so on. But the program would still run and play the game successfully, which is exactly what you want to do for these courses. Is let the teacher give you credit for the things that do work. Um, a few people named their class wrong. So it's supposed to be PA3, um, and so a minor deduction for that. Um, Make sure you stick with uppercase class names, right? And make sure if you're trying to make a file, a class called PA3, you put it in a file called, PA3.java. Or if you want a class named tree with an uppercase T, you put it in a file with an uppercase T, tree.java. And you can make a file like this that has a class tree with an uppercase T. But if I just say Java C PA3 to compile your main program, your main class, right? As it's going through, it finds out, oh, I need a class named tree, uppercase T. It will look in your directory for a file named tree.java, uppercase T. If it doesn't find it, it's going to say, hey, you don't have a tree.class. And it looks like a compile error. So you have to know that there's a file with a different name, lowercase tree.java, compile that by hand. That'll get you your class tree with an uppercase T. I did get a stick game Easter egg, which was awesome. Secret entry to the stick realm. So, good stuff. And you can totally Easter egg PA4. That's part of the creative freedom. Let's see what else on PA3. Generally, if people were able to update the tree in memory, they were able to write it out to the database file. Oh, that was the other thing that there were a few point deductions for. So if you just say Java PA3, it's supposed to read 20q.txt. If you put a command line argument, it's supposed to read that database file instead of 20q.txt, and that wasn't always the case. There are a few submissions where it used a different default, or it didn't use a default, or it asked on the command line for a prompt and so on. That can be your signature, the stick game. You could probably make a whole programming language around the stick game, where like you make different instructions based on how many sticks you take and how many you start with. You make a whole degree in it, right? You get a BS in stick game. Excellent. That would be an awesome degree. All right, any other questions on PA3 or questions on PA4 so far? I know we just started PA4 Friday. You can make a whole religion, All right, so let's break down PA4 into some possible steps. A Tetris OS, wow, cool. All right, so PA4, we're playing a stick game, right? So where do you start? one place to start would be making something that displays a grid of dots right. That's going to get you into painting, and I want to talk about painting this morning in more detail. But work on something that displays a grid of dots and try to pick up your mouse clicks. Right? Write something so that when you click your mouse, it figures out what line should be drawn. And this is arithmetic thing. I'll show you some equations and some ways to break that down. And yeah, maybe start with a 4x4 or something smaller than 9x9. That's a good idea, because if you can do this for a 4x4, you can do it for a whatever by whatever. And then once you know how to identify, a line corresponding to a mouse click, then you can start saying, okay, so how am I going to draw lines? And so this is where you start to make like a box class that has booleans for each of the 4 edges of the box, and then make a board which has an array of boxes. So what's your board entry look like? Box 2-dimensional array, the board equals new box 8. So and you want a constructor for your box class that'll set these booleans to false, for example. But if you get this set up, then you can do something like when you click, somewhere in the playing area, run your code that figures out, based on the coordinates of that mouse click, what 2 dots you're trying to connect, figures out what box that belongs to, right? Which of the 64 elements in this array you're drawing a line on, and then goes into that box and sets the boolean for top, bottom, left, or right to indicate that that line has been drawn. And then try to update your painting methods so that in addition to drawing the dots, it also draws lines wherever you have lines drawn. And at that point, you're more than halfway done. At that point, you're responding to events, you're doing the basic drawing, you're updating, and you're driving things out of memory. And that's a really nice framework to build on. But we gotta tackle a few things to do that much. We've got to talk about painting. So paint and repaint. And we've got to talk about coordinate arithmetic. But let's talk about painting and repainting first, sort of the mechanics in Java with Swing of how we do something like draw an array of dots, a grid of dots. And so remember, in Swing, we don't get to say, let's draw a dot, right, anywhere that we want. We can't just wait for a button press, or we can't make our main program say, let's draw a bunch of dots, right? Drawing always happens from one location, which is the paint method. Oh, I didn't want to do that. What? I've already got a painter? Alright, we'll make a painter too. Alright, so let's get us a boilerplate main program. So just a good old J-frame. We'll call it main. And same thing that we set up last time, I'm going to go ahead and put a drawing panel in here. So I'll make a J panel, put that in here, I'll make it kind of big. I'm going to go ahead and give it a border so we can see it. So I'll stick with a bevel border. And I'm just going to put a button in here so we have something to play with. Maybe I'll put a pair of buttons in. Oh no, we're spamming passwords. I can never remember password when I set that to be my password. All right, so let's just draw some stuff. Did we crash Eclipse? I think we crashed Eclipse. So, so I'll act cool and switch over to another window. So remember, you have a J panel. It has a method called paint. It's public, it returns void, it takes an argument of type graphics. And inside here is all the code that should do whatever you want to do to display stuff in this J panel. Alright, yep, I crashed Eclipse. Excuse me while I fix my system. Alright. Bitwarden. Cool. I use KeyPass. That seems to be a pretty good open source password manager. Alright, where'd we leave off here? We should have a J panel and 2 buttons. Looks like my buttons didn't make it. Alright, so this box in the middle is a J panel, right? We want to do some custom drawing on it, so we need to be able to override the paint method, because the default paint method isn't displaying anything. So we want to make our own paint method. I don't know what that is. So let's go into the source. And that panel that's being created inside with the beveled edge is a J panel. I'm going to change that to be a my panel. And I'm going to move the declaration of my panel outside of this method, because I'm going to want to get to it from other places. So this is the panel where we're going to do our drawing. And I'm going to do something in here. I've mentioned keyboard shortcuts, so I keep using Control D to move down in VI, and Control D by default deletes the current line. So I'm going to go into Preferences. I'm going to type Short, which is short for shortcut, and I'm going to go to Keys, and I'm going to find that binding. So I'm going to sort by binding and go down to Control D. And that Control D, when I'm editing text to delete a line, I'm going to undo that. So now I can Control D to move down and Control U to move up. So if you've got bindings, you can do that. It's not really great to be posting Eclipse code. Yeah, I guess I could post it on Canvas. The issue with this is that 90% of this code is generated by Window Builder, and there's like 1 or 2 lines that are actually like interesting. But I can post this up if you want. Don't just try to reverse engineer it verbatim though. Control D is down, Shift D is delete, and DD is delete the entire line. Shift D deletes from your current spot to the end of the line. Alright, so it's not happy about my panel because we haven't defined a my panel class yet, so let's go ahead and make that. So we'll do a new Java class. We'll call it my panel. And if you want, you can come in here and you can set up a super class, but I'm just going to do that in the editor. So I'll say it extends JPanel, and then I'll come here and hover and say import JPanel. Alright, so now my code is happy, right? Main is not complaining. I'm going to change my my bounds on my JFrame so I don't have to constantly drag my window over from the other screen. So if I run this, there's my panel, but nothing's being displayed because we haven't written our own paint method. So here's what we're going to do. We've got a my panel, which is an extension of JPanel. So it's already got the default paint method from JPanel. We're going to override that method. We're going to write our own paint method. And so let's do something like this. Let's go into the my panel class. And let's make a paint method. And I don't know. So let's run let's use X. Let's start off with X equals 0. X is less than the width of whatever getWidth returns. Well, what is getWidth going to return? We're inside my panel, which is a JPanel. So this is going to use the getWidth method of the JPanel class. And if you look at JPanel, there's a getWidth method that it inherits from component, which says return the current width of this component. So getWidth will tell me, how wide my panel is. And so I'm just going to make a for loop. I'm going to start off X at 0. I'm going to go up to the width minus 1, I'm going to increment by 50s, and inside there I'm going to do y equals 0, y is less than get height, And I'll do Y's by 50s also. And I'm going to fill an oval. So I'll use X and Y for the X and Y coordinates, and I'll make it a 5 by 5 dot. Alright, so I'm doing a bunch of fill oval statements, but I'm iterating in X and Y, so this should give me a nice little grid of big dots. And so if I run this, right, I got some dots on my screen. And you notice that, you know, that nice bevel that I had around my panel has disappeared. It used to have, you know, that marking so I could see where the panel is. Well, that's gone away. Now, I never told it how to draw that bevel. There's nothing in the paint method that says, you know, draw a line up here and then draw a faint line below it to make it look like a shadow and then draw a line on the left and so on and so forth, right? Everything that is used to paint the panel, to make the panel visually appear, is inside this method. And right now, the only thing that paint is doing is drawing a bunch of ovals, separated by 50 in this case. Yeah, definitely don't hard code things like 50 and so on and so forth. Set those things up as variables. So what we really want to do, and if I, you know, change the name of this to something other than paint, then when it wants to draw the panel, it's not going to call haha paint, it's going to call paint. And if I don't define a paint here, it's going to call the default paint method. So if I do that, right, we get an empty panel, but we see the border on it here, right? So dark lines there and white lines there and so on. So how do we get back that behavior and also do the thing that we want to do, which is draw an array of dots? And instead of, you know, figuring out how to draw that border ourselves, all we're going to do is just punt. We're going to say, hey, you know, that paint method that you used to use, go ahead and use that. Right? So in the very beginning of our paint method, we're going to put in one line which says super.paint. We're going to call a paint method from the super class, which is jpanel. So this will call the original paint method. And it needs an argument of type graphics. Well, we happen to have an argument of type graphics. It's called G. So we can go ahead and pass that. And now when we run this, we've got our beveled outline and we've got our dots that we created. All right, and you're going to want a super.paint probably in the beginning every time that you write a paint method to do whatever the original paint method did. All right, now paint is the only place where we can do any drawing. And it's really hard for us to call paint because we don't have a graphics object that's appropriate. And we don't want to call paint because we want swing to be the only thing that's calling paint. And if we start calling this method ourselves, we're going to get into conflicts. We're going to end up painting while something else is trying to paint and so on and so forth. So we need to manage this carefully. And so let's explore that by adding some response to events, or maybe by crashing Eclipse. So let's take those two buttons and let's use them. Let's change the spacing between our dots. Okay, this is not something you do for the programming assignment, but it's a fun thing to do. Come on, you can do it. There we go. All right, so let me change this button to be plus, and let me change this button to say minus. All right, and let's make this J panel variable. So let's make here's our J panel. Let's make a pair of integers, x increment and y increment. And let's change x by increment and change y by y increment. So we can adjust the spacing between these dots. So far, you know, exactly the same behavior, and our buttons don't do anything. All right, so if we want to have our button draw the dots closer together or further apart, we're going to come in here. We're just going to tie some code in. So let's go into the plus button, and let's draw the dots further apart. So we want to make X ink and Y ink larger, right? So if I just do this, it's going to complain, right? It doesn't know anything about X increment. So what do I need here? How do I increment the value of X ink so that when I draw my dots, they're further apart? Yeah, exactly. So these increments are part of the MyPanel class, right? It's this X ink that I want to increase. It's this Y ink that I want to increase. So, and I did typo these, but that's not the problem. So what's the name of the panel containing these things? It's this thing called panel, right? That's an instance of MyPanel. So let me make this name a little better. Let's take this panel and call it something other than panel. Let's call this play area. Right, and if I change it in here, it'll change it in the source code. So now play area is a new J panel. So here what I want to do is I want to increment X ink in play area. So play area X ink equals play area X ink plus 5. I could have said plus equals 5, you know. Alright, and I'll do the same thing for Y. And if I run this, I can hit the plus button, and nothing seems to happen. Right? I've got code, I'm changing the increment size. But remember, I'm not painting when I click the button. All I'm doing is changing something in memory. I'm changing the value of a variable, X ink, which is going to get used right here in the paint method when the paint method gets called. Now if I redraw this, suddenly my dots are really far apart. And sometimes if I occlude this and then bring it back into view, sometimes not. But if I change the size of this, you'll see my dots get further apart. So what's going on here? The mouse click is changing the value of some variables, my increment size. The paint method will use that increment size in order to figure out the spacing it wants between the dots when it draws it. But I don't get to call paint. It's not updating the panel until you start messing with the panel itself. Exactly, yes. Right? Swing is in charge of calling paint. I can't call paint myself. So we do have a method that we are allowed to call, though, which is repaint. And repaint does not cause paint to be called right away. Repaint is simply a request to the window manager saying, hey, when you have a chance, please call paint. And it might happen really soon, it might happen not so soon, but it should happen eventually. So now what I'm going to do is, after I've updated these, I'm going to say repaint. And this asks for paint to be called when it's possible. And so if I run this, now I get immediate reaction to my button press. It is a little bit concerning, but not too bad usually. Think about doing Android development, for example, where you have a cell phone with all these things going on, right? Lots of processes running, lots of hardware being manipulated, and you've got an application that that wants to send a text message, right? Well, you know, maybe the radio is in the middle of doing something else. Maybe it's in the middle of sending a text message from some other application, right? You kind of need to say, hey, you know, dear Android, I would like to do such and such, and trust that it will you know, hear you and get to your request in an appropriate way. So yeah. So it's basically about working inside a larger system, and Swing is a little bit of that, right? Because there's different things going on that can be affecting the display of, you know, that panel, for example. And so, for example, you know, if I had resized that window, Swing is going to be repainting it, and maybe in the middle of that repaint, something calls my code which says, oh yeah, let's paint some dots, right? Well, you know, that's potentially going to make the code look kind of funny. All right, so let's complete this. Let's add the code for this. But let's decrement these. And let's repaint. So now, you know, I can make my dots further away. I can make them closer. And if I make these too close and my x increment goes down to 0, now I've got an infinite loop, right? I've got a for loop where x is 0, x is less than width, x plus equals 0, and that's a problem. And so, yeah, that's where it's a problem. So what's happening here? I'm in an infinite loop in the paint method, right? My paint method is not exiting, which means that if I try to click my plus to undo this, it doesn't work, right? Why? Because Swing is in the middle of its paint method, right? Everything is event driven, and something happened that caused Swing to say, okay, time to call the paint method. And until that paint method is done, it's not going to get to the point where it says, okay, let's check for mouse clicks, you know. The click has been registered, but Swing can't dispatch those calls. So we're stuck right now. And, you know, I can resize this, and it's doing all kinds of strange things. I can cut off the bottom of my button, you know. And you're pretty much out of luck at this point, right? So, I mean, we can terminate the program, but, you know, this is the nature of event-driven stuff. We always need to do something and get out, right? So if there's a potential for that in here, I would do the following. Right, I'd throw in a little safety check. And now if we decide to make really small dots, we can do that, but we can still come out of it. Repaint is where we shine, yep. Yeah, exactly. So that's a perfect explanation in chat. So repaint is the method that we call to say we want paint to be called when possible. And then swing will at some point decide, okay, it's a good time to call paint. I've got someone who wants it called. So swing will call paint for us. And similarly, if we resize a window or if something else comes on top of it and then goes away, if there's any reason why the window needs to be painted, swing should call paint. But there's no reason that swing knows of just because we pressed a button that it needs to repaint. So we have to ask it to do that repaint for us. All right, we need a margin. How do we add a margin? Because, yeah, right now our dots are kind of like flush on the wall. Is there a get margin method? Well, there might be, but let's just make one ourselves. So we just want to leave a little bit of space around the edges here. So how much space would you like to leave? Yeah, it would be a constant. 50 pixels sounds good. So let's do this. Let's go into the panel and let's set a margin. So let's just leave some space. And so instead of starting from 0, let's start from margin, and instead of going up to get width, let's go to get width minus margin, and y equals margin, and y equals get height minus margin. I think Eclipse has spell check. And so if we run this, and let's go ahead and make our dots really small, right? And you can see we got this nice border around there. Hopefully it doesn't autocorrect. Sometimes it does. So yeah, so this is a bit of a balance to find, right? We do want to take advantage of things that have already been done for us as much as possible. So we don't want to write the code to, you know, display the box and the boxes on the top and the X and the dash and the plus and all that stuff, right? But to some degree, we do want to do things ourselves, maybe even if they can be done, for us, right? So when you're experimenting, when you're trying to learn, I would tend to err on the side of doing more things yourself, even if you're reinventing the wheel. But then, you know, when you've got, 30 minutes left to finish something, definitely leverage what's available already, right? Well, let's add another button. Oh, we only got 4 minutes. I don't want to get too fancy. Yeah, let's make the margin the same as the dot spacing. So there's a couple of ways we can do this, right? In here, when we change the spacing, we could change the margin, right? Or in the paint method, before we do our drawing, we could set the margin. I would probably prefer to set the margin here, because there may eventually be multiple things that adjust the dot spacing, right? The X ink and the Y ink, but if I adjust my margin inside here, I can't go wrong. So now as our dots get smaller, our margins also get smaller. Nice. And we could make it, you know, based on the window size. Unfortunately, our J panel is not going to grow and shrink. Right? We can change the size of this and our J panel is just kind of like sitting there. But how could we make our panel in here grow and shrink with our panel out here? And there's a couple of things we could do. Well, okay, there's three things we could do. The first one is magic. The second thing would be to use a window manager that automatically made this thing grow. Yeah, magic's always a good option. The third thing would be to use an event. So we could say, you know, add an event handler, and we could do component resized. And in here, we could say, what did I call my panel? Play area. Why can't I set my height? This might be where we exit the class. So the idea was we're going to set the height and width of the J panel every time that J frame resizes. And I think we have to use a different set method, like set dimensions or... I'm a little unsure, but let's try this. So what can we set? We can set the bounds. We can set bounds X, Y, width, height. Set size, width, height. Alright, so we're going to call width and height on this object, which is the frame itself. We're going to bump them down a little bit, and we're going to set the size of the J panel accordingly. And just for good measure, we're going to call a repaint method on the play area to make sure that gets run. And there's some dots, and now let's redraw this, and there you go. Alright, so that's just in some examples of connecting components. Yeah, this would be a big dots game. Most of this is not, you know, part of PA4, but the basic notion of like drawing these things and so on is. So yeah, I'll go ahead and push those two Java files up to up to canvas, just make sure you remember that when you're looking at them, most of this code is not code that we wrote, so don't spend too much energy trying to understand, you know, the set border, new empty border, etc., that kind of stuff. All right, we are past time, so I will see you tomorrow in office or in class or both. Have a good afternoon. See you next time.